Hello students, this is lesson U5A07a. By the end of the lesson, you should be able to say I can apply inverse sine, cosine, tangent to solve for angles. So in the past couple lessons, we talked about the use of sine and cosine to solve for sides, right? And just to recap, the meaning of something like this, okay, is you're given a triangle, okay, and when you're asked to find out what sine of theta is, you're asked to find out what is the ratio between the opposite to the hypotenuse, right? And cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Those are the ratios, okay? So if you know the particular angle, okay, and then you can figure out the ratio. Well, what we're going to focus on today, or in this video, is, well, what happens if we're trying to go the other way around, okay? Let's say we're not trying to solve for a side within this ratio. We're not trying to solve for a side in the ratio, but instead we're trying to go for the angle instead, okay? What happens then? Well, as it turns out, okay, it's done in a very, very similar manner. If you know the specific ratio of opposite to hypotenuse, okay, we can then determine what that angle is. And then similarly, if we know the specific ratio of the adjacent side to the hypotenuse, we can then determine what that angle is. And lastly, if we know the specific ratio between the opposite to adjacent side, we can then figure out what that angle is. And we call this function the inverse sine, inverse cosine, inverse tangent functions, which is given by this. So let's just be careful here with the notation. I have this -1. This is not the same thing as a negative exponent. No, it's not. Okay, so what this is saying is we are undoing the sine function. Okay, so a synonym for the inverse sine or inverse cosine or inverse tangent, we refer to this as the arc sine or arc cosine or arc tangent. Okay, so this is often referred to as the arc or inverse functions. So we would use this if we're trying to figure out what that unknown angle is. Let's take a look. So in this problem here, okay, you're asked to find what angle W is, which is this angle over here. So how are we going to do that? Well, we are given two sides now. You're told the side opposite of angle W and told the side adjacent to angle W. So which one are we going to use? Let's make an educated guess. If you thought to yourself that we're going to use the tangent function, then you're absolutely right. So we recognize that 2 is opposite of W and 4 is adjacent to W. So therefore, we can say, and X here is the hypotenuse. So therefore, we can say tangent of W is equal to 2 over 4. That's nothing new. But what is new is we can apply the arc tangent or the inverse tangent function to figure out what W is. So W, in return, is equal to arctangent of 2 over 4. And we would punch this into the calculator. So we're going to punch this into the calculator. To get the arc trig function, what you would do is you press second and then tangent, and then you're going to punch in 2 over 4 and enter. And being that this is in degree mode, okay, this is going to be 26.56. I mentioned in the previous video that whenever you're working in, whenever you're trying to figure out the angle or you're entering an angle into the calculator, just make sure that your calculator setting is in degree at the moment. All right, so going back, we know that angle W will turn out to be 26 and change there. Pause the video to see if you can figure out what are the missing angles, or angle I to the nearest thousandths. Hopefully you had some time to think about this. Again, recognizing what is side length 2. 2 is adjacent to I. 15 is the hypotenuse. And side length I is opposite of angle I. So let's try to figure this out. So I know that because I have sides that are adjacent and hypotenuse, I'm going to be using cosine. So I know cosine of I is equal to 2 over 15. But here I'm trying to figure out what is angle I. So to do that, I want to take the arc cosine function. So arc cosine of 2 over 15. I end up with I is equal to 82.338. We do the same thing. Pause the video to see if you can figure this out. Hopefully you had some time to think about it. We are figuring out what angle C is. So therefore, because I know we're dealing with opposite hypotenuse, we're going to be using arcs. We're going to be using sine. So sine of C is equal to 10 over 12, or C is equal to arc sine of 10 over 12. So therefore C is equal to 56.443.